All right. It is now 1:30, so we are going to go ahead and begin. I'd like to welcome you all to today's webinar. Today's topic will be roadway safety enhancements, safety countermeasures. Before we get started, I wanted to touch on the webinar controls that you see on your screen. Right now, all attendees are in listen-only mode, so you're all muted at this time. The questions pod is where you'll type any questions or comments that you have. Feel free to use this at any time, and we'll have several points during the presentation today where we'll stop to address any questions that you may have. Finally, if you see the materials button right next to that, and you see that we have those both highlighted on the screen, um, on the materials button, you should have one handout which you can click to download, and this would give you a copy of the presentation for future use. My name is Tally Faulkner, and I'll be handling the technical support for today's webinar. If you have any issues during the webinar, you can reach out to me in the questions pod, or you can also email us at arltab@uark.edu. So I'll be checking both of those things and monitoring the emails. So again, feel free to reach out at any time if you have any issues with anything. The instructor for today's webinar is Stacy Williams. Dr. Williams is the director of the Center for Training Transportation Professionals and is also on the faculty of the Civil Engineering Department at the University of Arkansas. This webinar is sponsored by the Arkansas LTAP program, and Patrick Thomas with RDOT is the program manager within RDOT. Today's webinar will generate 2 hours of Road Scholar credit through the Arkansas LTAP program, and you will receive a certificate, which will probably be mailed to you by the end of next week. Keep in mind that you must attend the full webinar to receive a certificate. Finally, if you have a group attending with you today, please let us know who is attending with you so that we can make sure all attendees receive a certificate. To do that, please send an email with your list to arltap@uark.edu. And with that, I'll turn it over to Dr. Williams.
Hi, good afternoon, everyone. Hope you all are having a good day and getting ready for the winter storm. If you're in the middle part of the country or the south, I know everybody's kind of getting prepped for that. We are too. If you're in another area, enjoy your weekend. It'll probably be better than ours. Today, we are going to be talking about safety countermeasures. And if you were in the webinar earlier this week, we talked about data-driven strategies for safety and how to use the data that we have, how to collect other data, and try to really zero in some things that we can do fairly efficiently and effectively by using the clearinghouse for safety countermeasures, that crash modification factor clearinghouse, to be able to come up with some different methods that we might be able to use. But we didn't really talk about those countermeasures, so that's really what we will focus on today. So the first thing that I would like to do is to launch a poll, and I've got a typo in there and I could not get it edited, so excuse that little mistake, but I'm curious, what safety countermeasures does your agency currently use? Rumble strips, we've got high friction surface treatments, safety edge, roundabouts, and pedestrian hybrid beacons. And you should be able to select multiple answers on that. So I'll give you a minute to look through that. And if you're participating as a group, maybe talk amongst yourselves. All right, I'm going to go ahead and close that poll and share the results with you. Looks like a large percentage of you are using rumble strips and roundabouts, not so much on the high friction surface treatments. Several of you have indicated that you are using safety edge, and lots of you are using pedestrian hybrid beacons. So very good. I'm going to close that, and you should see the presentation again on your screen. All right, so when we are talking about countermeasures, we're trying to figure out what type of crash we're trying to mitigate and be able to really match the problem that we have with a potential solution that fits, is feasible, economical, and will change the outcomes of a situation in a particular setting. Maybe it's a horizontal curve or an intersection or that kind of thing. Now, a countermeasure is typically something that is designed to counteract the problems of a particular type of situation. So that countermeasure will be designed for maybe one thing or a subset of the type of crashes. So for instance, centerline rumble strips we might put in place to try to mitigate head-on crashes, but that may not help us so much with running off the road crashes. So you see that they're targeted for certain things, and we have to figure out if that item is going to help, but we also need to think about, will that countermeasure inadvertently create a dangerous situation for a different subset of crashes? So that is something that can happen. So figuring out what our target crashes are, what are the common problems in your area, and that kind of goes back to what we talked about last time. Now, selecting a countermeasure, we want to look at a number of factors. First of all, cost effectiveness, because I know last time a number of you indicated that you have a desire to do all of the necessary things to improve safety, but you can't afford to do everything. So we want to come up with some ways that we can really get the most bang for our buck and to reduce those fatalities and serious injuries as much as possible within our budget. So that has to be within the context. And so you might think about your facilities. Do you have a high-speed facility with limited access? Are you focused more on rural town centers that have a lot of vulnerable users, which would be pedestrians and bikes? Maybe it's a suburban arterial with driveway accesses that causes the most problem. Maybe you have more of an urban central business district type of setting. So the setting that you're in obviously is going to have a big impact on the types of countermeasures that you will select. Now, when you're selecting those, we definitely want to consider what is the anticipated impact on crashes. We want that reduction to be as large as possible. And then think also about the differences in frequency and severity. There may be locations that have frequent crashes, but they're not that serious. A small fender bender is something that, of course, we want to address, but it might be better for us to really focus on where we have a more serious type of injury or fatalities occurring. So thinking through what exactly do you want to address? Is it the fatality and serious injuries? Are you trying to target all crashes? Can we target all crashes, or do we need to kind of separate that and do what we can? Think about also your economic impact. How long will this countermeasure last? So is it a kind of a short-term fix, medium, maybe it's a long-term, forever type of fix? What do we know from what others have done? And that goes back to that crash modification clearinghouse of those values and studies that others have done. What has been that response and what do we expect? So if there have been some proven countermeasures, we certainly want to use those and kind of build on the successes that others have had. And then sometimes there are some trade-offs that we really can't measure. It's hard to put a dollar amount on safety, because when you start looking at serious injuries, we can certainly assign hospital costs, that's a dollar amount. But when you try to assign a value to a human life, that's a little bit more difficult to do. And I think we could all argue that maybe that's not even appropriate. So some of those trade-offs, it's hard to put numerically when you think of it in that context. Now, Federal Highways has a list of proven safety countermeasures. They have, I think they started with 9 or so a number of years ago, and they continually added to this list as new countermeasures have been implemented and studies have been done on those. So they've kind of proven their worth and put into context what situations that they're beneficial in. And so Federal Highways does have a page on their website, and they split this out into certain countermeasures that are most appropriate for different types of crashes. One of the most important ones that we see a lot in rural states is roadway departure or run off the road crashes. And so we'll see some details on enhanced delineation, rumble strips, median barriers, some roadside design ideas, with clear zones and such, safety edge, wider edge lines, and that type of thing. When we consider intersections, there could be things like backplates with the retroreflective borders, corridor access management, dedicated left and right turn lanes, reduced left turn conflict intersections, roundabouts, that's a big one, yellow change intervals. So lots of things that can be done. And this is a great resource to go to and just look at the ideas. It's a bigger toolbox. So not every tool works in every situation, but the more tools we have access to, the more we can make those decisions. And they have a list for pedestrians and bicycles, like bike lanes, visibility, uh, pedestrian refuge islands, walkways, hybrid beacons, and so on. And then there are some that really are cross-cutting, and they are applicable to a number of situations, like lighting, local road safety plans, friction management, safety audits, and then speed management. That's kind of a big one because we do know that speeding certainly can cause accidents, and in those accidents, the higher speeds tend to result in more serious injuries. Now, in Arkansas, we have a big issue with roadway departure. That's one of our focus areas. And 74% of fatalities there are kind of broken down into different categories. Like, what else do we know about that? So taking the data, and we see that 37% of those fatalities are young drivers, 63% are male drivers, 58% of those accidents happen during daylight, 25% have no seatbelt, 23% speeding. Almost half of those are on weekends. So I think that's very telling in the types of trips that are being made that are involved in these types of crashes. 35% happen during a morning or afternoon commute, and 14% are also at an intersection. So since we know that that's a big deal, let's talk about some roadway departure strategies. So when a vehicle runs off the road, let's think, first of all, we want to keep that car on the road. So they need to navigate, they need to keep it between the lines. So our first goal will be to think of ways that we can keep the car tracking where it should be. So what safety countermeasures will help us with that? We can increase enforcement, do road safety audits and that type of thing. But then if we cannot keep those cars on the roadway and they happen to go off on the edge or just slightly outside of that traveled way, can they recover and get back on the roadway? So that's a second strategy. And then if we cannot get them back on the roadway, then what can we do to reduce the severity of the crash? So that'll kind of be our focus in stages. So roadway departure, nationally, about 51% of fatal crashes are run off the road. That's typically higher in rural states. 27% of those are head-ons, 25% rollover, 19% are trees, or you could put that in context of just a crash with a fixed object. 25% of those are at curves. So we see that that's kind of an overrepresented portion because a curve is a very small portion typically of the overall roadway. 76% of curve-related crashes involve single vehicles. So this is not necessarily an interaction with another vehicle, and that changes our perspective on how we think about these countermeasures. And then why do drivers run off the road? We got to kind of get into the mindset of what is causing this to happen. So if you see, of course, in rural areas, we have animals that run out onto the roadway, and that is not something that is an interaction with another vehicle, but certainly changes our attention, reaction times, decision-making skills, and a very short time frame to make those decisions. But drivers can run off the road just from not paying attention, loss of traction, narrow lanes. So we've got a lot of different things that we can pinpoint to try to make this better. Now, if I know that curves are part of the problem. What if I could take curves out of the equation? Well, that's not realistic. We can't straighten out all the curves, but we might be able to make some changes to alignment. I know that some jurisdictions have a policy that in a horizontal curve of, say, greater than, or having a smaller radius or sharper curve, so to speak, they actually require a little bit more roadway width so that vehicles have a little bit of forgiveness on tracking in that area. It's not really straightening the curve, but it does give you a little bit more roadway width to work with. So those wider lanes at just that sharpest part of the curve can help. You can add super elevation, and these are things that might be done when you are doing maintenance on the roadway, repaving and that sort of thing. You can make some minor adjustments that will help along these lines. Another thing to look at is the quality of the pavement in those horizontal curves. Again, it is something where it's not just a straightaway, so you have to have that hand-eye coordination and track through there. If you are driving a large truck, big trailer, dual tires, and you have fairly narrow lanes, not only do you have the risk of not staying within the lane, but you're putting a lot of force on, a lot of stress on that pavement near the edge. So the picture on the right, you can see that broken, deteriorated pavement along the edges. And so now we no longer have a shoulder, so the shoulder forgiveness is gone. And once that pavement starts to break apart within the lane itself, we're really narrowing the effective roadway width. So that makes it even harder to track, or we're creating bumps and things that kind of shift vehicles. And if you are in one of those larger trucks with the dual tires, sometimes you get off on the edge of that, may not even realize it from the driver's perspective. And so causing that deterioration then has some safety impacts on down the road. So one of our solutions, of course, would be rumble strips or rumble stripes. And this is a series of indentations that are ground into the pavement edge. It creates noise, vibration, so that's something to get the driver's attention. So remember, our first goal was to keep the driver from running off the road in the first place, keep them in the lane. So as soon as they start to leave the lane, that pavement has something there to create that noise and vibration to alert them. Hey, pay attention. And maybe it was that they looked away for a second. Maybe they're getting drowsy. Maybe they were looking in the rearview mirror at something different. Who knows? But this will get their attention and allow them to make that correction. A lot of the newer vehicles now also have the lane assist, and it can create a vibration or kind of vibrate the steering wheel or create a sound that tells you, hey, get back in the lane. So those are good things. But we're looking more at the roadway. What can we do as the roadway agency? Now, those rumble strips can go at the shoulder. They can go in the center line. And sometimes we have rumble strips in the travel lane. Think about as you're maybe going downhill and coming to a stop sign that might catch drivers by surprise. If you have trouble with folks running a stop sign, you can put transverse rumble strips across the lane to get the driver's attention and alert them to slow down as they approach that stop sign. Now, rumble strips and rumble stripes are very similar, but not quite the same thing. Rumble stripes are painted, they're placed where that edge stripe or centerline stripe would go. So the stripe is actually painted on top of those indentions. And one of the things this will do for us is increase visibility at night. When you pave and then grind in those indentions and then put the paint on top of that, it has a more variable surface. So if you look at retroreflectivity, sorry, having trouble saying that word, but when it reflects, you've got a lot of different angles for that paint to reflect from the headlights. And if it's rainy, foggy, bad visibility, you've got a little bit more chance of that showing up. So it does actually increase visibility. Another thing to consider with these is what type of roadway width do you have to work with? If you have a nice big wide roadway, 12-foot lanes, 4 to 6 foot shoulders, you've got plenty of lane to choose whichever one you want. But a lot of times on county roads, you don't have enough width to put something outside that exterior lane edge line. So if you put them in the same place, you can get the effect without needing additional pavement width. Originally these rumble strips and stripes were used on freeways. So it was kind of implemented on the more national scale, the big roads, you might say. But seeing what those benefits are, they're now more common on rural highways, county roads, and other types of roadways. Now, shoulder rumble strips can be constructed using a number of different methods. The most common is the milled, but they can also be rolled in, they could be raised, and they could be formed, like on a concrete pavement. Most of the time, well, 90+% of roadways in the country are asphalt. So of course, we're going to see these more commonly on asphalt roadways. Now, the milled is the most common because you can go in and form these after you've paved the road. It doesn't have to be done during construction. So it is a safety feature that can be added when the road is already in place. The rolled type have to be done as the pavement is being placed, so that can only be done during an overlay type project or maybe new pavement construction. There are also the raised or the more of a bump instead of a dip. And that's something that you might see in a warmer climate. We don't want to do that in the colder climates because when the plows go through to scrape snow off of the roadway, they can peel those off. But in a warmer climate, that can be helpful. Let's say you have a really heavy rainfall and there's so much water on the road that it's getting difficult to see the pavement markings, but you can feel those bumps. And if they are raised and have the reflector, then you might be able to see them a little bit before you hit them. So that's an advantage. In terms of size, these are typically about a 1/2 inch deep. They're going to be about 12 to 16 inches in length. And if you're standing on the roadway looking at them, that kind of feels like width. How wide do they stick past the edge line? But they're measured that way in length. The width is actually how far are they longitudinally down the road, and that's usually about 7 inches. And these are placed 1 to 2 foot spacing on center. Now, early on, I mean, there's an obvious benefit, but one of the concerns was if we start grinding into a new pavement surface, is that going to cause that portion of the pavement to deteriorate more quickly? And are we going to have other problems that really create issues that weren't intended? Looking nationally, a lot of the early research does say that there's no evidence of early pavement deterioration. I'm sure all of us can also look at cases and find some place where that's not totally true. But one of the issues is that when we pave, we place the longitudinal joint at a lane line. A lot of times we do have a joint between the lane and the shoulder. If that is true, and if that joint was not constructed well, and we put rumble strips right on top of that joint, that definitely could be an issue. Since we're putting depressions in the pavement, water runs downhill, it's going to collect in those low spots. We also know that water and pavements are not friends. So we don't want to have water just standing in those depressions for a long period of time. One idea was to place a fog seal so that after those areas are milled, you spray a fog seal over that to help kind of make it more impermeable to any water damage that might happen. Overall, that was kind of deemed not necessary and also not monetarily beneficial. One thing that can happen is if you place those rumble strips and then you decide that that roadway needs to be repaved, is it going to be a problem to place another layer? Or maybe you decide to widen that road and what used to be the shoulder is now part of the lane. I have heard some folks say that you don't want the rumble strips to be underneath where a wheel path would be, but if you can keep it out of the wheel path, then that's okay. If you were changing your roadway so that you had a different number of lanes and you were shifting travel patterns, then that could be an issue on a notch and widening project, and some have chosen on a notch and widening to just cut out the section that had the rumble strips to avoid any of those issues. If you were to come back later and put a chip seal over an area that had rumble strips, you can still, chip seal is very thin. It's a surface treatment, and you can have still the effect without having to replace those rumble strips. But a number of agencies, especially local agencies, have looked at taking asphalt roadways and then placing a chip seal to try to save on maintenance costs. So now if we have rumble strips, is that going to cause a problem? It definitely can work. They're not quite as defined, but you are keeping that basic shape. But in some cases, they have reported that noise and vibration actually increase, even though they don't look quite as defined. And there's not been a huge report of delamination for overlays. And part of that is we shouldn't have a whole lot of traffic over here on the rumble strips. Obviously, if they do their job, that's probably what happened. But by and large, it's not enough traffic that it's really creating the type of distresses that we would see if it was handling a lot more of the traffic. Now, rumble stripes, again, these are the ones where the pavement markings are applied to the rumble. So this gives us greater protection of the pavement marking, because people tend to get off of it pretty quickly. Wet weather, if you look at the paint, is kind of making that rumble strip a little bit impermeable. That can help. But also, if you have the stripe and the rumble in the same location, you kind of depends on your drivers, but maybe your vehicle wear is a little bit better. Plowing is a little bit better. And then you get that additional greater angle of reflection, so more visibility. The thing to remember is that once you decide to put these in, you're not just budgeting for placing the rumble strips, you're also going to have to replace those pavement markings, so make sure and budget for that. And the rumble stripes at the center line obviously are for head-on crashes and can also help with opposite direction sideswipe type crashes. Now I've included some schematics here. This gives you a little bit of detail of how those can be placed. And you see on the left side, we've got centerline rumble strips, which means the rumble is between the two parts of the center line. The rumble stripes, the yellow lines are closer together, and the rumbles are milled in on top of that and then repainted. Now, how successful is this? We're all pretty familiar with it, I think, but nationally, there's some pretty good evidence that there's a definite reduction for fatal and injury head-on and opposite direction sideswipe type crashes. For the shoulder rumble strips, roadway departure with fatal and injury crashes overall dropped about 36%. We would like it to drop a whole lot more, but that's pretty good. Centerline rumble strips in urban areas have reduced crashes about 64%, and rural areas 44%. Michigan had a study that they did overall on roadway departure crashes. Their rumble strips and stripes dropped crash numbers 38%. And New York showed roadway departure crashes dropped by almost 80%, which is fantastic. And crossover crashes at the center line dropped about 57%. So those are definitely some convincing numbers that say this is worth the effort. Now, things to consider. The purpose of rumble strips is to counteract driver error. It's not going to correct a deficiency with the roadway. So let's say that your curve is too sharp for the posted speed limit or the warning recommended speed, or you've got some issues with super elevation, or maybe some skid resistance issues. This is not going to fix that. Some issues have been encountered with bicycles. If you have bicycles that are commonly using that roadway, you need to make sure you have at least a 4-foot shoulder. Make sure that the integrity of the pavement edge is in good shape. Make sure that you have enough width, of course, to handle it. And usually for the width of shoulder, that outer edge does get a little bit crumbly, but make sure it's not crumbling too close to the actual travel path. Potential for maintenance, again, we talked a lot about that. This is something that is not necessarily effective for spot installation. Now, it has been used for like just putting in a horizontal curve. So if you have a curve area, that obviously could be a good place and a useful place to use rumble strips. But for the cost that it takes to have someone mobilize and come out to do this, it's really felt that you might as well put it everywhere. Now, noise. This is a concern if you have a lot of residents in the area, because we've all heard what that sounds like. If a big truck especially hits those rumble strips, you can hear it. And that's the whole point. But we want the driver to hear it. The neighbors don't necessarily enjoy hearing it all the time. So sometimes you will get complaints from that regard. Centerline rumble stripes are likely to be placed on the longitudinal joint. So we said that's kind of the weakest point in the pavement. If we can avoid that over at the edge of the lane at the shoulder, then we would want to do that. But at the center line, it's pretty rare for you to not have a pavement joint at the center line. So that's something that we might see a little more deterioration for those types. And then think about your future widening projects. Where do you see this roadway going in the future? What will the wheel path locations be? What's the timing of that? And so on. For any of these countermeasures, we want to make sure that we can afford to do them, especially for rumble strips, which say that it's not that effective for spot installation, so we have to do a lot of this. In general, anywhere from 10 cents to $1.20 per linear foot, which equates to around $500 to $6,000 per mile. And it depends on a lot of things. I know that's a huge range for cost, so it's hard to budget, but it does depend on the size and the type of the job, the type of pavement. If you're going to put these on a concrete roadway, it's a little more involved to install them on concrete roadways as opposed to asphalt. And then if this is something that you're bringing in a company to mill in these rumble strips, as like that is the project, as opposed to adding this on to a paving project that you're already doing, that can change the price. Mobilization. If you want to just try it out, this is something that early on a lot of folks kind of struggled with. They wanted to try it but not do it everywhere, because if it didn't work, then that was a problem. But to have a company mobilize to come and do a small project typically costs a lot more per linear foot. And then, of course, think about your traffic control, lane closures, make sure that you dispose of the millings correctly and all of that. But by and large, this treatment shakes out at about a 50-to-1 benefit to cost ratio, which is wonderful. So this is obviously something that's been very helpful and has made an impact on reducing those run off the road crashes. So it's something that you could use to implement as a policy, and it could be that you want to have a company come in and do a lot of, place these rumbles on existing roadways, or you might implement it as a policy that going forward, all newly paved roadways will include rumble strips, that meet certain criteria. So a recommended policy by federal highways is that for all freeways and rural highways that have speeds of over 50 miles per hour, this is a good thing to add. Recommended for rural or urban corridors where significant numbers of roadway departure crashes have been identified, of course. And then centerline rumble strips should be considered for 2-lane undivided rural high-speed roadways. And this is, typically where you're going to see a lot of those more serious head-on type collisions. But if you're seeing that in an area, this is definitely a worthwhile solution to look at. And then involve your stakeholders. These will be the neighbors that may not like the noise, but if they're aware that this may help folks from running off the road and crashing into their fence, and they may not have to repair that fence as much, maybe they would be okay with that little bit of extra noise. RDOT in particular has set a policy that for roadways with a speed limit of greater or equal to 50 miles an hour, where you also have a lane and shoulder that's at least 14 feet, then they're going to put these rumble strips. They are not really for heavily populated or suburban areas. And then also we want to make sure that these do not deter passing zones. So that's specific to the center line rumble strips. And make sure that if you have passing zones, that that's not going to be an issue. All right. So I've got a break right here for us to have questions. Has anything been posted in the questions pod?
Yes, we have had one question that's been posted so far. And yes, if you guys do have any questions either now or as we're progressing through here, please feel free to get those posted in the questions pod and we'll get to them at some further stopping points here. The question that I have is, what are mumble strips?
Okay, good question. Mumble strips are very similar to rumble strips, but they have a slightly different shape. It's more of a sinusoidal waveform, so to speak, rather than just a rounded cut for each one of those rumble strips. And that does kind of take the edge off of the sound. So in areas where you feel like you need that, but noise is a sensitive issue, mumble strips are supposed to be a little bit quieter, but still provide that vibration that gets the attention of the driver. So yeah, great question.
Okay, well, I believe that is all that we have at the moment.
All right, very good. So other things that we can do for roadway departure type crashes might be enhanced delineation. So especially in horizontal curves, it's easy to run off the road if you can't see where you're going. So if we don't have good signage to alert us that a curve is coming up, maybe those pavement markings are worn out, we don't see those, that can be an issue. So we want to provide information to warn and prepare the driver, make sure the driver is paying attention, and that we can tell them what speed they need to be going to not have issues. And then that also helps them pay attention, maybe gives them a little bit of increased visibility, so time to do what they need to do. Now, signage, this is kind of a tricky one because signs can be very helpful, but if we put too many signs, I think drivers just sort of blank that out. They quit paying attention because there's a sign everywhere. And so it kind of loses its effectiveness if you overdo it. In the same way, we can put those advisory speed warning signs, that extra placard that goes on a curve warning sign, like the one in the top right corner says curve 25 mile an hour. If your speed limit on that roadway is generally 55 and you know that the curve is 25, that's a big difference. So that tells me, hey, this is a really sharp curve coming up. I need to slow it down. If you put curve warning with a 50 mile an hour speed recommended, that's only a 5 mile an hour drop. So I'm probably going to kind of ignore that. I think a lot of drivers would do that. The other thing is if you put up a lot of those warning speeds and drivers drive along and see those, maybe it says 45, there's always a teenage boy that says, yeah, but I can do that at 60. And it depends on your vehicle. It depends on the pavement. It depends on a lot of things. But sometimes drivers will look at a speed and say, oh, that's just for big trucks. That's not for me. And so some of those signs do lose their effectiveness if they are, if the drivers don't feel like it's serious. So what else can we do to improve that communication? Well, we can do some things that get extra attention, like a flashing LED curve warning, blinker sign. We can do different fluorescent yellow sheeting. We can use optical speed bars. PennDOT uses a curve advance marking on the pavement surface itself. So again, we're just trying to increase visibility, preview that sight distance. And so the first question will be, what do you have now and what are your current policies? Are you using maybe speed limit changes in areas that have a lot of curves, like a windy road, or do you keep the same overall speed limit and then use curve warning signs? Do you use more of the orangey yellow or more of the greenish yellow fluorescent? The older style is more of that orangey color, and some of the newer styles have that more fluorescent, kind of a brighter green yellow. And when it's something new, that does get the driver's attention. If you have a different type of sign, for instance, in this curve, we've got a 90-degree curve, and we have some type of a posted speed limit, but if we know that speeding is prevalent, having a sign with just that straight arrow to the left can mean something a little different than the chevron or sharp curve coming up. You know, it's not just a curve, it's literally a 90-degree turn. So making sure that when we choose our signs, they are very specific to the situation. Right. Now, also looking at crash rates, roadside characteristics, what are the consequences of running off the road? Is it, you know, kind of a bluff and you're going to fall 60 feet, or you're going to run into the trees, or is it a nice open field where you could kind of correct and be okay? So that will also dictate how serious we need to get with that information. We can use enhanced delineation. One of the pretty easy things to do is use a wider edge line. We can go to some more durable markings. Sometimes we restride, but then that paint wears away. And if it's not that visible, then that's something that's going to make it more difficult for drivers. If we need maybe something that's going to work better in snowy conditions or lots of rain. Maybe we have times with different weather where you can't see those pavement markings even if they're new. So we need something maybe that stands up a little higher. So we can do post-mounted delineators that have the reflective badges on those. Right, the different colors of yellow sheeting that I had mentioned. There's a picture, this kind of an older picture from RDOT, is changing to that brighter color. And in the picture, you can see the older style looks kind of dark. The newer ones are still, even those are still not the really greenish color, but they are brighter. So making sure that you're getting a good quality sign that has a bright enough color to send that message and be visible to the driver is important. Now, maybe you already have signs and you need something that makes it more visible. Adding flashing beacons to that is going to keep them from kind of blending into the background. Remember, if you're going to put something like this, everything that's on a post becomes an object that could be hit during a crash, so make sure and use your breakaway designs. But putting these blinky lights, that really gets the driver's attention. Again, not something to use a whole lot, or we kind of zone out and tune that out. But if it's in certain more dangerous locations based on your crash statistics, this can be really informative. There is a roadway in Arkansas. When I first started college, driving up the hill to Fayetteville on Highway 71, there was a sign that told it's a dangerous and curvy ahead, and then they had a part of the sign that told how many fatalities had happened on that roadway within the last year or 2 years. And that was a sign that really got my attention. That's kind of scary. You don't see that everywhere. So something that's different will get the driver's attention until that driver uses that roadway over and over and they get used to it. Maybe they don't pay attention. Now, the saving grace there is that if they use that roadway quite a lot, they're probably pretty tuned in on how much they need to slow down to navigate that turn. One of the other issues with some of this additional visibility, if you're going to put blinking lights, you need a power source for that. And if you're in a rural area, there's possibly no electric. Some of the solar little jobbies that sit on there can collect sunshine and make that work so that you can use those in remote locations. But then if you're in a lot of trees, maybe that's a difficulty. So make sure you can come up with a worthwhile power source that will make that work at all times. Here's another example of some of the LED blinkers. This is a curve warning sign, and you can see the little lights that have been added all around the diamond shape of that sign. So it's something that will add some visibility, get the driver's attention. And then another example here is for the same kind of thing. Got the solar panels there, just another application. And in this one, you can see that we've got a little bit of wearing on some of the pavement striping. So maybe there were some other things that could be done in conjunction with these different signs. And then curve advance markings. This is the one that Pennsylvania DOT was using. This is something that should be placed in advance of curves. However, one thing that is not good with this particular photo, the horizontal bars that go all the way across look like stop bars. And so really this is a good idea, but should not be used with stop bars that could be interpreted as a stop sign. I've got another picture coming up on the next slide, but one of the things to look at here is that you are seeing something that's like, wow, that's not normally there. Now I'm paying attention. So grabbing the attention of the driver, and make sure that's done far enough in advance that you have the right sight distance and that visual perception gives the driver a clear idea of when that curve is coming up. In this example, this is the same type of thing without the stop bar. It just says slow. This needs to be placed about 400 feet after the standard curve warning sign. The text should be 8 feet, so fairly large, so you can see that at driving speed. It can be used with arrows, but again, not with the solid bars that look like stop bars. And then make sure to think about maintenance. This is a good idea because it should be right in the path of vision for the driver. However, it's also in the wheel path. So over time, these markings do tend to wear away, at least in the wheel paths, pretty quickly. So tire wear is an issue. If you could somehow space that where it was a little bit less of an implication, that would be helpful, but it does need to be right there in the way of the vision of the driver. Now, optical speed bars is an interesting one. This kind of gets into a lot of the psychology of the driver and what they're thinking, how they perceive things, and it's kind of fascinating. It's designed so that you see approximately 4 bars per second. And then the spacing, if you think of it like a picket fence, if you're driving down a roadway and there's a picket fence and you see those pickets, and that they kind of have a speed to it as it goes by. But as the spacing narrows between them, now it looks like those picket fence bars are going by faster because they're closer together. And that gives the perception that you're driving faster, which makes you want to slow down. So this one is kind of a mind game, but you can see in the picture how you've got those optical speed bars. It also gives some guidance to get the car maybe in the middle portion of the lane, so you've got a little more forgiveness rather than coming into the curve at the edge of the lane on one side or the other. I think that's about all there is on that. Here's an example of how those work. One of the issues with that is it's not hugely expensive. It's paint that gets put out on the roadway. However, your crew is in the roadway, so there's a lot of traffic control to consider, and measuring and painting is kind of labor intensive, even though it's not an expensive item. And this is what that looks like. So as you approach the curve and get closer, those speed bars get a little closer together, which is just a visual, hey, you need to slow down. All right, what about costs for these items? Signs and paint in general are fairly cheap when you look at it in the grand scheme of things. So consider your initial costs, your maintenance costs. Thermoplastic is definitely more expensive than just your regular paint or latex, but it also may last up to 4 times longer. So given that trade-off and how much time you want your crew spending out on the roadway getting that put in place, that's just a decision that needs to be made. So kind of checks and balances there. Signs, you see the picture here. This is what tends to happen to signs in rural areas a lot, and they have to be replaced. We do have to maintain retroreflectivity requirements, so keep that in mind. But any post-mounted delineators might be justified for roadways that have more than 1,000 vehicles per day. The post-mounted delineators, costs are different, depends on where you get them, if you have someone else get them. But signs tend to run about $25 to $35 per square foot. And then think about your maintenance and cleaning. So everything that is implemented, think about when will this have to be refreshed? When will the sign have to be replaced? And make sure that you budget that into the overall game plan. All right, any questions on that?
Looks like we have not had any new questions posted as of now. Well, actually, one did just come through as I was saying that, and I'll read it. It says, I've seen optical speed bars on an urban downtown street, but I question their effectiveness in such a busy environment with lots of pedestrians. What would you say about their use?
I would say, gosh, an urban downtown street, typically those would be straightaways, maybe not, maybe there's a curve there. One of the things, in addition to using those speed bars to help slow someone down, it's kind of a new thing, so it gets your attention. And I do like that it comes in from the edge lines, so it does help you kind of visually center your vehicle within the lane lines. That is probably one of the bigger benefits with pedestrians being there, in addition to hopefully having some slowing down. I think one of the issues that we would run into, though, is that once you get used to it, you quit seeing it. So I think it's a good short-term thing, but it may have limited value later on. If it is an area where you have lots of commuter traffic, that's especially going to be true. If you have a lot of tourist traffic, though, I think it could continue to work for a longer period of time. So it kind of depends on your users.
All right. Well, I believe that is everything.
All right. Thank you so much. All right. Next, we're going to move into high friction surface treatments. This is something that's going to help keep the vehicle on the road by providing some additional skid resistance. So specifically on horizontal curves or areas, maybe a curve leading to a stop sign, those types of things. This is where we might see a greater instance of cars that have to slam on the brake, they end up sliding, and then we have those bad consequences. Now, horizontal curves only make up about 5% of highway miles, but as we saw earlier, about 25% of fatal crashes happen there. So the percentages are kind of lopsided, indicating that horizontal curves do create issues. Now, to put in some extra skid resistance, this is something that we do to the roadway itself. We're not really addressing vehicle concerns. You know, if somebody's driving around with old worn out tires, they're not going to have as much grip. So if bald tires on a roadway have a bad outcome, we can improve the roadway. We can't really improve the tires. So we're doing what we can to address what we have control over. High friction surface treatments depend on high quality aggregates and angular, polish resistant types of materials. And specifically, if you use the formal version of high friction surface treatment, that's going to be a calcined bauxite. That is in conjunction with an epoxy resin. It's an engineered resin that has a polymer type binder, and it's placed kind of like a chip seal, but it's not a chip seal. It's got different materials, but the process of placing it is kind of the same. Now, looking at surface texture on pavements, we've got micro texture, macro texture, mega texture, and then just plain old roughness and unevenness. So really the mega texture is just a rough roadway, but macro and micro texture tend to have the most impact on our skid resistance of vehicles. Micro is going to be that little bitty stuff, the grit or the rough texture of an aggregate particle that helps grip the rubber on the tires. The macro texture is also important though. That's a little bit larger, so it can kind of grab the tires, but part of what that's doing for us is giving water a pathway to move and hopefully run off the roadway without interfering in that and making a barrier between the surface and the tires. HFST, that's our high friction surface treatment aggregate. We mentioned the calcined bauxite. Bauxite is actually only available in 3 states in the country. That's Arkansas, which is here, Alabama, and Georgia. Calcined bauxite typically, though, is brought in from overseas. China, India, and Australia all do that. So basically taking a bauxite material and baking it in an oven. That's the calcined. It heats it up. And we want that to be fairly small in size. So 1 to 3 millimeters, or about 1/8 of an inch. That's the size that we're talking about. So not only do we get some of that macro texture, but we're adding a lot of micro texture. In terms of construction, we can apply this over asphalt pavements. You can put it on concrete, but most of the time we see it on asphalt. Application rate has to be designed for that epoxy resin. So we're putting down that resin first and spraying this material, can broom across, and we're going to put down, that's basically the glue. We put the glue down on the existing pavement, and then we sprinkle this very, very textured, very hard, very durable aggregate on top. We want that aggregate to get about halfway embedded in the glue, and then we're going to sweep off what's left over. So in that context, you can see why it's placed in a similar manner as chip seal. It will tend to shed for up to a month, but then we are left with a surface that's got a lot more surface texture. Now this can be done manually, or it can be a mechanical installation. The manual installation is a lot cheaper. So unless you have a lot of locations where you want to place this, it's usually economically more beneficial to place by hand. And so you have the truck with the epoxy, you go place that and try to get that all spread out. Keep in mind you do need the little raised, I don't know, fancy construction golf shoes is what I call them. I'm sure they have a much more technical name, but the risers on the shoes, because your feet will stick to this stuff. You can usually put down about 200 or 300 square yards per hour manually. Mechanically, you can do a whole lot more than that. So 1,500 to 2,000 square yards per hour. You do need to remove any existing thermoplastic pavement markings so that we get a good bond. And then make sure it's applied in clean, dry conditions with a minimum temperature of about 50 degrees. So this is more of a spring and summer type of an activity. Now the cost, it is kind of expensive, particularly if it's a mechanical installation. Anywhere from $25 to $35 per square yard. The aggregate is expensive, but also the binder is expensive. So when we improve the quality, we're improving quality of both components. So if you're used to, say, a chip seal, it's got aggregate and it's got the emulsion. Those are both relatively cheap factors, but we took both of those and really ramped up the quality, which is also going to ramp up the price. Aggregate $350 to $500 a ton. However, some municipalities have done something similar to this, not used the formal version of the calcined bauxite, but used a very hard type of aggregate, if you have that available in your region or your state. Something that's very much harder, very angular, very gritty, could be used in its place to get some of the same benefits without the cost of the bauxite. Now, the offsetting feature here is that this is not an application that we're going to put everywhere. We're only going to put this in specific locations that have proven to have issues for folks running off the road or losing traction. So maybe it's a little downhill stretch leading into an intersection. Maybe it's in a horizontal curve. But it has been very successful. And when you look at that overall, since there's not a lot of area at a time, that does sort of offset what the cost sounds like. And then it does tend to last quite a long time. 10 years has been reported. Sometimes the high friction surface treatment has lasted longer than the asphalt that's around it. But it's not something that you want to spend a lot of money on when you're going to do an overlay program or some kind of a rehabilitation project and it gets covered up. So make sure and think through that. Now, this does not prevent all hydroplaning accidents. It's definitely going to help, but it's not a magic fix for hydroplaning. If you have contact between the surface and the tire, it's going to give more of a bond there. But if you have too much water to have that connection, it's really not going to fix that. So make sure that you correct any rutting problems or drainage issues before you put this treatment down. It's pretty good to withstand the winter weather, snow plows and that kind of thing, but it's also using a very, very hard aggregate, which can actually be hard on your equipment on the blade. So it is too rough for a rubber tip plow blade and will tend to tear those up. Now, sometimes this will get placed and there will be some shedding, and especially under a manual installation, some areas get done better than others. And if that coverage gets kind of spotty, it may look bad, but any of that material that is still glued down on the surface is still serving its purpose. So as long as you have some in the wheel pads, it really should still continue to perform. It's just not going to be pretty. Now, one of the issues with this is that this does not increase driver comfort. What I mean by that is some of the things we do to increase safety. Maybe we make the lanes wider, or we make the curve have a larger radius so the curve's not so sharp. That makes the driver feel more confident, which then also allows the speed to increase. They feel like, oh, I can go faster here. It's not going to be an issue. But we're not doing anything here. We're not adding super elevation. We're not straightening anything out. We're not doing anything different. So it doesn't make the driver feel like their vehicle will perform better. And so that's actually a good thing. Now, if you have a poor quality roadway, like surface deficiencies, again, rutting, that type of thing, we're not going to be able to correct that. This is 1/8 of an inch aggregate that's scattered out, so there's not enough thickness here to correct any of those type of things. Do not patch a pothole with this stuff. So just something to think about. And usually it's reported to not be an issue for a motorcycle or a bicycle. However, if they do have an accident, I've heard people say the road rash is unbelievable. So hopefully it's enough traction that that doesn't happen, but it would be much more rough on a person that did have an accident. Now, in terms of successes, Pennsylvania did a lot of work with these, and in their early work, 100% reduction in all types of crashes. So this is pretty amazing. Kentucky was reporting around 85%, 85% reduction in crashes in wet weather. South Carolina reported 57% reduction, 24-to-1 benefit to cost ratio. And then a national study was done on these for specific to intersection crashes. And of course, intersection crashes can be due to a number of things, but 20% reduction happened when the high friction surface treatment was placed. The other important piece here is that there have been no reported increases in crashes after the high friction surface treatment was installed. All right, so all these things have been a way to get the driver's attention, keep the driver on the road. But what if they run off the road? then what? What if we still have not succeeded? Now we need to look at how to reduce the consequences of running off the road. So one thing we can do is look at the lateral clear distance. Where are the trees? Where can we do things to improve visibilities, have fewer obstructions? An obstruction can reduce visibility, but it can also be something that becomes a fixed object in a crash. Are there things that we can do to the ditch? Maybe reduce the slopes on the roadside and ditch slopes. That can help prevent rollover accidents. So maybe they still run off the road, but if the ditch was more shallow, the car wouldn't roll over. Maybe it would just be a property damage only type of an accident rather than a minor or major injury or worse. Also consider the direction of vehicles. When they are driving through, if they run off the road, consequences in one direction will typically be worse than in another direction. So you might need to do something different on one lane of the roadway than the other. And then try to remove or relocate any objects in hazardous locations. You see in the picture that really pretty brick mailbox. Lots of folks like these because they don't want their mailbox to get knocked over, and that's understandable. However, that becomes a fixed object that is usually really close to the roadway. So that can be a major hazard for a lot of local agencies in residential areas. And I know some agencies locally here have started a policy that you can no longer install those types of mailboxes. A lot of them are grandfathered in, they're still there, but anything that you can do to get things like that moved a little further back off of the roadway, and the mailman doesn't like it because they have to pull into a different area. But think about anything in that general vicinity of the roadway is a fixed object that could become an object in a crash. And try to use the breakaway designs. It's better to save a life than to have a pretty mailbox. All right, I think I have 2 slides out of order. So the next solution is the safety edge. And this is something that's designed specifically to reduce the pavement edge drop off. It can help reduce crash severity. It's not really going to keep you from running off the road, but it can help, because what happens if when we kind of just barely run off the road and one tire drops down off of the edge of the roadway? Well, if that's a vertical edge, vertical drop off of more than about 2 inches, if you're going 55 miles an hour, it's nearly impossible to get back up on the roadway without overcorrecting and getting yourself thrown into oncoming traffic. So that tire scrub is a big deal. Let's go back here. Now, I don't know why that slide is where it is, so I'll just skip that for now and hope that works itself out. But crashes on roadways with drop-offs are 4 times more likely to be fatal. So if we have a nice paved shoulder, this is not an issue. If we don't have a paved shoulder, we usually have an aggregate shoulder. So we pull up that material and it looks like it's all nice and pretty solid, but over time, that's going to wear away. So when we don't have a paved shoulder and that roadway gets a little bit older, we tend to see these types of drop-offs. When you pave normally, at the edge of the screed, we have what's kind of a vertical, it gets mashed down and has a little bit of a wavy shape there. But in general, it's kind of a vertical shape. But if we could change that so that we're not going to expose a vertical drop-off and maybe make that more of a sloped edge, then I'm going to be able to have something there that will allow drivers to correct and get back onto, get back onto the traveled way without accidentally throwing themselves into the other lane. With Safety Edge, they advertise that up to a 5-inch drop-off can be traversed and get a car safely returned to the traveled way without an accident. And that's a big drop-off. So to use safety edge, first of all, you've got to figure out where this is. You've got maintenance personnel that can probably tell you where a lot of these drop-offs are already. The mailman, the trash man, all of these trucks that travel the edges of the roadway and stop routinely, they probably know where all of these drop-offs are. But collecting data is pretty straightforward. Just go around, identify the roadways with that edge drop-off, and with those visual surveys and measurements, you can get a lot of data pretty quickly. Now I'm going to try to roll back here to this picture. Now, the safety edge is one of the Federal Highway's proven safety measures, and it's really just a fixture that goes onto the edge of the paver, at the edge of the screed, where instead of that vertical end gate, you've got a fixture that bolts on and forms a 30-degree angle. So as the paver goes by, it's forming an asphalt wedge at a 30-degree angle, and you don't have that vertical drop off. And you still pull up your graded material up to the edge of that, just like you would on anything else. But when you don't have a paved shoulder, this is kind of giving you a little bit of a paved shoulder, if you want to think of it that way. Now, this it's pretty easy installation. You buy the fixture, and it's just 2 or 3 bolt holes. There are a couple of models of European pavers that have you may have to cut a hole to have it bolt on. Most of them bolt on very readily, especially if it's a US made paver. They are removable, and you can also attach it over to the other side to flip it around and use it on the other edge. So depending on which side you're on, which lane you're paving, what direction, it's pretty versatile and helps out. All right, so when to not use the safety edge and when to use the safety edge. So if we have new construction, that's an obvious, pretty easy one. If we have reconstruction, if you have anywhere that a paved surface meets an unpaved surface, that's something that we want to do. But this is happening. It is attached to the pavers. Obviously, it has to be at a point where we are paving. So it's not something that you can just go add on. You would not run a paver down and try to attach this little asphalt wedge to something that's existing. It does have to be during a construction project. So policy-wise, this is something that you could implement for all new and rehabilitated types of pavements. Times that you don't want to use the safety edge is when you have a forest slope to your ditch, maybe you're off the edge of the roadway, that's steeper than the safety edge would give you. That's not going to work out well. Obviously, you don't want to do this when there's already curb and gutter or a guardrail. And then remember that your paver extensions have to be moved in for narrow roadways, and just make sure that the safety edge fixture will fit within the edges of your screed for that. And then you may need to adjust for intersections, of course. In terms of construction, we're actually adding a little bit of width of pavement to the roadway. So that may bleed over into areas that currently have vegetation. So make sure and scrape that off before you pave. And also look at the break point. If you see the little schematic there at the top middle of that slide, you've got new pavement being placed over old pavement. The old pavement has a sort of vertical edge, and then you've got your wedge that's going to extend out further than that. You want to make sure that you don't create breakage. So the picture, I don't know if you can see my cursor right here, you can see how the way that that was placed created that fracture, and so the whole safety edge kind of broke off. So just pay attention for that, make sure that's not going to be an issue. In general, your safety edge should be invisible. When you're finished and you pull your graded material up on the sides, nobody's ever going to see that safety edge unless you lose your aggregate shoulder. When that falls away, you might see it. But the point is that it's there and it's going to help support that vehicle. But it's not intended to be a substitute for your graded shoulder. And now paving over rough surfaces. When we're putting this wedge over at the edge, if your outside edge of pavement is going over kind of a rough area, it's going to be a little bit more difficult. So make sure and get this smooth. This is true for any type of paving project. The smoother your material is that you're paving on top of, the more smoothly that paving project will go. So just imagine that if you have rougher surfaces than where the screed and the shoulder wedge attachment, it's going to be adjusting its downward pressure, and it's going to hit those high spots, and it's going to bind up a little bit more. So make sure that you can adjust that so that it doesn't ever catch on something or hang up or jerk the screed. That can mess up the smoothness on the entire pavement. If you are paving over a base with a varying longitudinal profile, same kind of thing. Remember that that screed functions with a free floating motion, and that wedge has got to float with it. You don't want it to hang up. If you're paving over softer surfaces, make sure that the edge, the front edge of it, doesn't dig into your shoulder material. And again, making sure that that shoulder area is prepped correctly will keep that from happening. And then make sure that your paver operator is keeping enough flow of material into that safety edge. You don't have to do anything special or extra as far as compacting the wedge. That was one of the thoughts at one time, that maybe we need a tag-along roller to help mash that in. That has not been considered necessary, but make sure that you have enough material that's being compressed into that wedge that you do get a decent density so that it works right. Use your standard rolling pattern. One thing that can happen is that the edge will kind of stand up. So if you think of that 30-degree wedge, but then when you get on the pavement with the roller, if you have a lot of further consolidation, you might have this shape before you roll it, and then it might squish and kind of push the top surface of it out toward the edge. And if that's happening, you don't have 30 degrees anymore. You have something that's closer to vertical. So flatten out that slope a little bit if necessary, and then monitor that. Make sure and watch it during construction that you're getting that 30-degree slope that you want. Now, what does it cost to do this? Relatively cheap from the aspect that you buy this thing one time, you can attach it to your paver and use it on as many projects as you want to. Somewhere in the neighborhood of $5,000, maybe a little more depending on the type. Some of the companies that sell this, Transtech sells the shoulder wedge maker, Advantage Paving Equipment sells the Ramp Champ, Troxler sells the Safety Slope. These are all kind of the same thing. And then Carlson Paving Products does the Safety Edge end gate. That's where they actually modify the end plate on the screed. And then that attachment, if you buy the attachment type, it can be removed. Now, I will show you this. This was done on a project sort of locally, and this is a homemade version of the same type of thing. So worst case, if you can't afford to get the actual device, it is possible to do something else. I wouldn't recommend this for long-term application, but the concept is there because it was felt like it was such an advantage to driving safety. All right, so that is all on Safety Edge. Do we have any questions that have come in?
Okay, it does look like we've had a couple come in. One, it says, can a notched wedge joint maker be used for this?
A notched wedge joint maker is typically for paving projects where you're forming a longitudinal joint, and it has, say, like it's got about a 1-inch notch, and then the slope part goes out at a 1 to 12. So it's much flatter than what you see for the safety edge. I know there are some similar things that are adjustable, but I don't know of any that are adjustable enough to get you up to that 30% or that 30-degree slope. So I'm not sure that those can be used interchangeably. Also, the fact that it puts that notch in there. So like for a 2-inch overlay, you've got 1 inch of notch, and then that 1 to 12 slope means that the other inch is actually spread out over a 12-inch width. And that would be a lot wider than what we would normally have as excess space available during a paving project for safety edge. Now that would be, if you just built it that way and left that as your shoulder, that's actually flatter. I don't think it's a problem, but monetarily, we typically are not set up to have that amount of real estate available to do a slope that flat.
Okay. And then the other one we have is regarding optical speed bars. Is there a range of travel speed where these are most appropriate to be used? For example, are they best used on roads with speed limits of 35 miles per hour or more, or are they not effective on roads with 25-mile-per-hour speeds?
That is a really good question. I know they're typically used in, like say a rural two-lane secondary type of highway. Um, and that works well because you have a significant slowing. But if you're already at 25 miles an hour, I don't know that you would see a huge reduction in speed because there's not a whole lot slower you can go at that point that would be significant. And most, I can't imagine a curve that you couldn't take at 25 miles an hour. Now, if you wanted to just have some extra pavement markings, I think the benefit, if you did do that, would be in maybe that more urban setting of just something else that looks different to make people pay attention because something looks different. You can't kind of gloss over that. And then, after you've done that for 3 months, you don't notice it anymore. But for newer drivers in that area, that's really about it. It helps center the vehicle within the lane and gives them something else that's not quite normal, so maybe they're paying more attention. Beyond that, I don't know that you're going to keep someone on the roadway based on a speed issue.
Okay, well, I believe that is everything that we have at the moment.
All right, very good. All right, let's look now at intersections. So intersections are obviously points of conflict because we have people going different directions. They have to pass through the same space to get there. So obviously those have the potential for accidents. Now there are over 300,000 signalized intersections in the US. Over 12,000 fatalities happen every year at intersections. That's nearly a quarter of all traffic deaths. And a lot of those are from red light running. So why do we see this happening? Well, obviously conflict point, but beyond that, it seems like we shouldn't have wrecks there because we have lights to tell drivers what to do. But it's really when the drivers don't do what the lights tell them to do, unless we just have a horrible mistake with the signal timing, there should not be a case where there's a conflict because the lights say who has the right of way. Everyone else has to stop or yield. But when the drivers fail to yield, or they're not paying attention, or they see the yellow light and think, it's just pink, I'll keep going. Maybe that's a shorter yellow light. We don't really know how long those yellow lights are going to last. And even when there's an all red segment in that signal timing, how long does that last? So when people don't do what they're supposed to do, then we have conflicts, and those conflicts typically have some pretty severe repercussions in terms of accidents. So one of the solutions here is roundabouts. So it's a circular intersection and it has a center island. There are no traffic signals, no stop signs, and they've been reported to increase traffic capacity by 30 to 50% compared to traditional intersections. So I've got a poll question that I want to pop up here for you. So give me just a second to load that. All right, that should show up on your screen now. How are roundabouts viewed in your jurisdiction? Might be that Everyone loves them. Drivers do well with them. Drivers maybe just tolerate them, or you might have mixed reviews, or you get lots of complaints. Give me a couple more seconds to finish answering that. All right, very good. It looks like most of you have mixed reviews, and we've got a few where the drivers simply tolerate them and a few that they feel like drivers do really well. Nobody said that they get lots of complaints, so that is encouraging. But early on, especially, public perception of roundabouts was, oh no, I'll never get to go. I like the green phase of the signal timing, and this is never going to work. And so maybe a third would be in favor before construction. 41% more would be strongly opposed than were in favor of that. But after construction, that overwhelmingly changed to about 2/3 being in favor of the roundabout. So let's look at some of the characteristics of these. It is, again, a circular intersection, and traffic goes counterclockwise. So you enter the circle and you have to yield to those who are already circulating within that roundabout. So there are yield signs at all of the entry points. But keep in mind, it's a yield sign, not a stop sign. The circles are typically pretty small, and that is a specific design to help increase curvature and force slower speeds upon entering that circle. And then if it is designed correctly, you should never have to change lanes while you're in the circle to get out of the circle. Okay, so you may have to change lanes if you miss your turn and need to stay in the circle, but overall, if you get in the right lane as you enter the roundabout, that should direct you exactly where you need to go without an issue. Now, part of the reason I blame Chevy Chase for the European Vacation movie where they get stuck in the traffic circle over in Europe, and it just seems like a horrible, scary thing. But a roundabout is not the same thing as a traffic circle. On the roundabout, the cars going into the circle have to yield. In a traffic circle, the entering vehicles have the right of way, and those already in the circle have to adjust. And that means they get overloaded with too much traffic and things kind of grind to a halt. So they don't function as well. In terms of pedestrians, a roundabout is not intended to have any pedestrians in the center portion of the circle, but in a traffic circle, pedestrians can cross into the center. And then for a roundabout, we have higher angles of entry, which means cars are forced to slow down before they enter the circle. And traffic circles have those lower entry angles, so cars go faster as they come in. The faster they move, the more often they make mistakes. A single lane roundabout looks something like this, and you can see on the entry areas to that circle, we've got a splitter island, and that separates the traffic going into the circle as opposed to that coming out. So we've got a little bit of distance separation there. And then also we design that curvature to deflect and slow down the vehicles that are coming in. And that splitter island does that as well as allow pedestrians to cross in two phases. So if you look here, pedestrians, again, do not go to the center of the circle. They're going to cross a leg of the intersection back here before the circle. So in theory, the pedestrian only has to watch one side of traffic at a time. They get halfway across, and then they have a place to stand and then consider the traffic exiting the roundabout before they make the decision to cross on over to the other side of the roadway. So splitting up those decisions tends to help make better decisions. And then there is an apron also. This is a traversable portion of that center island, because one of the things with our single lane roundabouts is sometimes they're small. So imagine that you had this single lane roundabout close to a school, and the school buses come out. Those are big vehicles, and we might need them to have a little bit extra room to make that turn. So we do typically have a traversable section and then a portion that is not traversable, or not intended to be anyway. Now, a multi-lane roundabout is a little bit more complicated in terms of design, but it's similar. All of these roundabouts are similar to the traditional intersection. So when you have multiple legs that convene at one place, if I say go to the intersection and turn left, what I actually mean in terms of a roundabout is go to the roundabout and go around 3/4 of the way and then exit. And that essentially does the same thing as making a left turn at a traditional intersection. So overall, the movements are the same. And when roundabouts were first being implemented, the signage that went along with them was the same as what we used for a traditional four-leg type intersection. And that was confusing because a left turn arrow looks like I'm making a left turn. Do I make that before the circle or after the circle? And there were some pretty terrible accidents or conflicts that happened there. The good news is that speeds are relatively slow in a roundabout, which does reduce the severity of any crashes that happen. In fact, years ago, I went to a safety conference over in England, and they drive on the wrong side of the road. So the roundabouts are backwards. And my husband was driving, and we were having to adjust to a lot of perception problems from being on the wrong side of the road. But we got in a 5-lane roundabout. And at this conference, they talked a lot about the roundabouts and how safe they were, and like 98, 99% reduction in serious and fatality type crashes. And so what I'm hearing is that they're so much safer. But looking at all of the cars in the roundabout, every one of them had skid marks on the side. So lots of side swipe crashes. The difference is a side swipe type crash is property damage only. An angled crash at a traditional intersection involves typically some serious injuries and fatalities. So we're talking about that reduction. Yes, it's a huge reduction in the very serious type of accidents. That doesn't mean there won't be some accidents, but we want to reduce that severity level, so that's good. Now, multiple lane roundabout is sometimes a little bit more complicated to drivers for them to figure out how to operate this, but in general, the right turn, if you have 2 lanes coming into the roundabout, you need to be on the right side. That's pretty intuitive. You're going to take that right turn. If you are going to go straight through the intersection, you're going to navigate through the roundabout, but both lanes can go straight. So the green car and the yellow car both stay in their lane, and they can both exit, and they're still in the lane they were in prior to the intersection. We have the ability to accommodate left turns. So instead of having a right turn lane, a through lane, or 2 through lanes, and a left turn lane, we're accommodating all those movements with the same 2 lanes of traffic. But the green car makes a left turn, goes around the roundabout, and comes out in the left lane on that 3rd leg. And then the additional piece here is that we are able to accommodate U-turns in the same system. So a lot of our 4-leg intersections do not allow for U-turns. There are also miniature roundabouts or mini roundabouts, and these are handy sometimes in neighborhoods where you have low speeds, something less than 30 miles an hour. They're not very expensive. They don't take a lot of right-of-way. However, because they are small, they have to be completely traversable. So this little center island, there are some pavement markings that tell us what to do, but a lot of folks will drive straight across. But if I brought a moving truck in here, I do have to have that traversable nature so that the moving truck can fit through. So sometimes those work well, and sometimes drivers don't quite do what they're supposed to do. Now, driver decisions. What do you have to do when you approach a roundabout? Well, first of all, you have to figure out which direction or which leg of this intersection do I want to end up in, and then pick the appropriate lane. So that means I've got to have some signage on the approach to make this critical decision in advance, enough that I can get myself in the correct lane. If it's a single lane roundabout, you don't really have that decision. But then also make sure your drivers know that they have to yield to those who have right of way. So the ones who are already in the circle have priority. They also have to yield to pedestrians that are crossing at the entry. And hopefully the way that you enter a roundabout, you're seeing that pedestrian and they're only having to cross one leg at a time. So they should also see you. One downside on the pedestrian aspect is that a driver coming into a roundabout may not be looking to their right where a pedestrian would approach. They're probably looking to their left to see who's coming around that circle, to see who they have to yield to. So you need to make sure that there's plenty of visibility for pedestrians that are entering that area. The other decisions that have to be made is to figure out when there's enough of a gap to get into the circle, and then again watching for pedestrians, and that's at the exit. All right, so decision wise, I would say that a traditional signalized intersection is a little bit simpler because you don't decide anything. You just have to do what the light says. You may decide whether or not to obey the light, but the light tells you exactly what to do. It tells pedestrians when to walk. It tells you when to make a left turn, when you can go through, and that sort of thing. The problem with that, even though it's simpler, if it doesn't work out quite like it was supposed to, the consequences of a mistake are much more severe. Now, sometimes we see these mini roundabouts used. This one's not quite as miniature because it does have some of this landscaping in the center, so it's not intended to be completely traversable, but it can be used as a traffic calming circle. You have to slow down a little bit to make your way around that. And if you do not let cars go completely across the middle of it, then they are forced to slow down a little bit, and that can be handy in neighborhoods. Pretty difficult for the big moving trucks though, and sometimes they'll just take a normal left turn and cut right across in front of the roundabout instead of making the circle. Right, so user education is very beneficial. And overall, I would recommend, and this is probably on a slide somewhere coming up, but when you decide to implement roundabouts and they're brand new for your jurisdiction, start small. Start with a one-lane roundabout. Let folks learn that, and then move to your multi-lane roundabouts. I think they're pretty common now. We don't have as much of an education issue, but that is something that if it is kind of a foreign concept, introduce that slowly and try to encourage that user education. Now, advantages of roundabouts: minimal conflicts. Everyone is traveling essentially in the same direction. So you don't have those right angle conflicts. You don't have left turn conflicts. Everyone's kind of moving in the same route. Your speed control is provided by geometrics. You're not depending on vehicles to see a speed limit sign or a traffic control device to tell them how fast to go. That's what it takes to make it through the roundabout. So when you force those slower speeds, you're allowing for more decision time for the vehicles that are coming into the roundabout. You have smaller sight distance requirements because you're just looking at merging in with those other folks that are already there, the ones that are pretty close to you already. Vehicles are slowing down and a lot of times more likely to yield to pedestrians. And of course, the crashes being less severe is a huge advantage. Overall, the delay for a given vehicle is lower. You may have to slow down, but you don't necessarily have to stop. When you don't have to stop, that increases some environmental benefits because you're not idling as much waiting at an intersection. Now, there's no priority given to certain movements. So some of our intersections, we have the major and the minor approach. The major approach typically gets priority for a lot of the design of that signal timing, but all of the intersection approaches are treated equally. Now, this could be an issue when you have a major arterial intersecting with a low volume minor street. There may not be enough gaps for that minor street vehicle to get into the circle. But in general, treating those all equally means that the side street folks are not always having to wait on a red light to turn to green to have a chance to get in there. So overall, it makes the intersection more efficient because it reduces the need for turn lane lengths, so you don't have as much pavement. All of those actions that are happening are a little bit more coordinated instead of you, then you, then you, the taking turns. And again, that advantage with the U-turns. It can be traffic calming because people tend to get a little agitated if they have to sit at a red light too long. It helps transition from a high-speed rural to a low-speed urban environment, and the driver feels like they're in control much more so than being controlled by signals. So I think that can be a huge advantage. If you think they're pretty, then the aesthetics are definitely an advantage. It does give an opportunity to provide some green spaces, but make sure that you think about visibility. If you put statues and trees and bushes and things and you're blocking visibility across the circle, sometimes it's not necessarily a bad thing because we shouldn't necessarily have to see all the way across, but visibility is important. But if you have an obstruction in the middle of the roundabout, make sure that it is large enough and marked well enough that somebody doesn't accidentally try to go through the middle of it. And it's surprising how often that happens. So make sure that if you're going to put an obstruction in the middle, make sure that everyone can tell that there is something in the way. And then from a maintenance standpoint, if you don't have a traffic signal, you don't have to maintain a traffic signal. And that is nice. Now, visibility. These are some of the challenges of roundabouts. Sometimes drivers cannot see the exit point, especially if it's not really a four-leg intersection. Maybe it's a 3 or a 5. So things get a little bit turned around when the drivers start going in a circle. It's helpful to see where's my exit point and is there some sort of a landmark, even if it's just a tree or something off in the distance that you can tell when you get to the place to get out. Driving in a circle can disorient older drivers in particular. Also, older drivers sometimes struggle with peripheral vision or being able to turn their head back to look over their shoulder for vehicles that are already in the circle. So if your entry curvature is too sharp, yes, it will slow the speed down, but then that driver has to look back over their shoulder to see who's coming. So make sure that you balance those benefits. In terms of safety, there can be an increased risk of crash with fixed objects, especially if you've got decorative things in the middle of the circle. It does take away your ability to have signal progression because there are no signals. So you don't have those platoons of vehicles that are moving down a pathway. And that means you can't, if you're in a driveway over at some business on the side and used to, if the normal system, you would say, well, when the light turns red, that'll catch all of those folks and I'll be able to turn out. Well, if you don't have a signal, you kind of lose that grouping of traffic. And so your side streets can actually have more of difficulty, especially if they are between the major intersections. It's also much harder to manage special events. So when we have a Razorback football game, all the signals are disabled and we've got emergency personnel directing traffic, trying to get them out of town and on their way back home. If you don't have signals, some of that could be done with signals, but if there are no signals, you can't do it. So you have to definitely depend on personnel to help manage those traffic patterns. And then again, that random exit pattern can reduce the number of gaps downstream from the intersection. And again, the folks on the side street may have some trouble finding some gaps, especially during higher traffic times. The spatial requirements for roundabouts can be a challenge, especially in some downtown areas. If you have room for a circle, you can definitely save on the approaches. You don't need as many lanes coming into the circle, but at the circle itself, you are going to take up some of the corners, so to speak. So if there are businesses, maybe there's a church on one corner and a bank on the other corner, and you decide that's a great spot for a roundabout, make sure that you can fit the geometrics in there, and also think about utilities. So how much right of way do you have available to form that circle, and make sure that the circle is large enough to handle the traffic. If you have a multi-lane roundabout, there are a few more decisions to be made. Again, you should be able to enter. If you're in the correct lane, then you should not have to change lanes while you're in the circle. But if there are multi-lanes, then maybe you got in the wrong lane and you do actually try to move over, or maybe other people are moving, or you're just worried because you don't know if that guy knows what they're doing. But it can be a little bit more complex regarding those decisions. Pedestrians may have a greater distance to cross, which could impact some of the timing. Think about the elderly and the children who may walk a little bit slower. If you have visually impaired pedestrians, make sure that that's not going to be an issue. Sometimes they have trouble finding the crosswalks because now it's not a straightforward 90-degree intersection. So the signs and markings are critical for making sure everyone in that system knows how to operate it. Now, one of the common mistakes here is that we have a multi-lane intersect or roundabout here, and we have both lanes that are marked to allow a straight through. So the red arrow that is moving on out of the circle could happen at the same time a car is entering the roundabout, and those two have a conflict point. So it's important for the ones entering the roundabout to understand that they are yielding not just to the outer lane of traffic, but also the inner lane of traffic. And that can be a difficult message to communicate. Another situation where a conflict point can be created is here where we have the wrong lane usage. So in this case, the vehicle in the outer lane was supposed to exit. And they had a straight through, which meant go on through and exit the circle. But it looks like their lane continues. So if they change their mind and think, oh, nope, I need to go around to one more street. So they stay in at the same time the inside lane vehicle decides to exit, then we have a conflict point. So the correct signage is very important to put information here. Do we have both lanes able to exit? Do we have only the inner lane able to exit, go on around, and this outer lane is a right turn only? So think about those traffic patterns and where you want people to be able to go, and then make sure that that is communicated. All right, in terms of our successes, changing from a two-way stop intersection to a roundabout, fatal and injury crashes here in the US overall dropping 82%. All crashes dropped 44%. Changing from a signalized intersection dropped fatal and injury crashes almost 80% and all crashes almost 50%. So pretty close on those numbers. And that is very encouraging. The cost of roundabouts, they're not cheap. I won't say it's a low cost measure that you can use, but if you're comparing that to the cost of creating a signalized intersection, don't forget the maintenance that's involved with that traffic signal maintenance. Really, if you have a single lane intersection, it's about the same. The multi-lane, though, is going to be more expensive, mainly because of the right of way. You need good lighting, so you will have some features there that have to be maintained. And usually cities like to make that area a little bit more decorative. If you have bushes and flowers and such that are in the middle of the circle, don't forget to include the cost of maintenance for that landscaping. Now, in terms of implementing roundabouts, know your users. Is this the first roundabout in the area? This is what I was saying earlier. Start with a single lane. Make sure that your drivers get a little bit of experience with that. Hold some public interest meetings. Let stakeholders ask the questions that they have, and then figure out, once your community is more comfortable with that, then start looking at policies. And a lot of communities are going to a roundabout first type of policy, that we're going to design a roundabout unless there's a convincing reason that that won't work. And it is a cost saving measure in the long term with regard to signal maintenance, and then also just the safety benefits. So look at all your alternatives, consider the geometrics, the capacity, feasibility, how will you maintain traffic during construction, and all of those kinds of things. But definitely roundabouts, there are certainly concerns, especially from the public, but they have proven to do a lot of good in a lot of situations. All right, any questions on that?
All right, looks like we do not have any questions at this moment.
All right, well, I'm going to wrap up with a section on pedestrians and just show you a few things here that we can do or consider for maintaining and improving the safety and visibility of pedestrians. So usually we see lots of statistics about intersections and pedestrians at intersections. And obviously, whenever a pedestrian is in the same general vicinity as a vehicle, if there's a conflict, the vehicle is going to win. At 23 miles an hour, a pedestrian hit by a vehicle will die maybe 10% of the time. At 58 miles per hour, that jumps up to 90%. And really kind of the cutoff is right around 40%, where a pedestrian is more likely to have a fatality when hit by a vehicle. So factors, of course, are speeding, alcohol, dark, if there's no sidewalk, if they're not at an intersection, all those kind of things. But pedestrian fatalities have really increased over the last, say, 15 years. So it is something that we definitely want to address. Now, part of pedestrian issues stem from lack of visibility. The first thing to do is increase the visibility of the pedestrian. And I love this graphic because it shows the pedestrian there just kind of fades into the wall. And if you are driving, you're at an intersection, you're trying to manage your decision process, and you're really focusing on the other vehicles because you don't want to run into them. And sometimes, especially if we're in an area that doesn't have a whole lot of pedestrians, we forget to look for them. And so anything we can do to highlight the presence of a pedestrian or separate them completely from traffic, but somehow decrease the exposure of that pedestrian, give them a little bit of protection, is going to help. And then if there is a conflict point, the slower the vehicle is moving, the better off they are. So, of course, consider the most vulnerable of those users, which would be the elderly and children. Now, one thing we can do is provide a median. We have to have enough right-of-way to do this, of course, but this is an area between the opposing lanes of traffic. And it's kind of like that splitter island on the roundabout. If we can give pedestrians one direction of traffic to worry about at a time, get them halfway across the roadway, and then provide a safe space there in the median, then they can focus on the other direction of traffic to continue crossing to the other side of the road. So those crossing islands can be raised, not necessarily, don't have to be, but they could be at mid-block, which keeps them away from the intersection. Sometimes that's helpful. But a lot of successes are here. Make sure our pedestrian crosswalks are very visible, good paint, all that kind of thing. If you have it's dusk dark and the pedestrian's wearing dark clothes and they're crossing not at an intersection, they just sort of wander out into the street, it is very hard to see that and adjust in time. So if they aren't paying attention to keep themselves safe, it makes it very difficult for a vehicle that's moving much faster than them to catch on to that. So these crossing islands are good for urban and suburban areas, curved sections where maybe vehicles have less visibility of approaching a pedestrian. Those multi-lane roadways, sometimes in multi-lane, there's a vehicle blocking your view. That makes it difficult, or a vehicle might block your vehicle from the view of the pedestrian. There are lots of variations for these mid-block type crossings. If you have lots of pedestrians and need more storage, you can use this dogleg shape where that median is almost all pedestrian storage. So by making it kind of zigzag before you cross the other leg of that roadway, that gives a lot more storage space so that more pedestrians can be safe inside those bollards that are providing some level of protection. The pedestrian hybrid beacon is a great way to increase visibility to drivers to let them know that there is a pedestrian that wants to cross. This can be done mid-block. Oftentimes, most of the time, that's where it is. And so it's kind of like a signalized intersections, but it's specifically for bikes and pedestrians. This is a beacon that has 2 red lenses above a single yellow. And so it starts off by flashing yellow. And what does that convey to the driver? Same thing any other yellow light does. Caution, slow down, it's about to turn red. So it goes from a flashing yellow to a steady yellow, and then it moves to a steady red. When it's red, that's when the pedestrian gets the signal that they are allowed to cross. And then after a certain time period, the 2 red beacons start to flash back and forth. And at that point, if it's clear, then vehicles can continue on. This only flashes or activates when the pedestrian signals, so there will be a button for them to push, and that's the only time it works. So if there are no pedestrians, then there's no interaction with drivers. They can continue on like they normally would. But it gives attention to drivers, but it really gives a lot of guidance to the bikes and the pedestrians to tell them when they should or shouldn't go. Pedestrian hybrid beacons, and a lot of times these are called hogs. So that's not necessarily an intuitive acronym, but this is something that is recommended to use only in conjunction with a marked crosswalk. It could be something that's very valuable if you have gaps in traffic that it's really hard for a pedestrian to have enough time to cross, especially on multi-lane roads. If it's intermediate or high speed, sometimes the pedestrian can get caught out there unawares. And if you have a lot of delay where pedestrians are having to wait a lot and not get there. You can include some public education efforts, but signage is typically the best way to go so that anyone who gets to that point, if that hawk is activated, there's no question what they should do. The colors and things are essentially the same as a regular stoplight, so they should know. But good successes with this: pedestrian crashes with the hawk in place down about 70%. All crashes down about 30%. Another way to increase safety for pedestrians and bikes is to do a road diet. And this typically will involve converting a 4-lane roadway into 3 lanes, which would be 2 through lanes and a center 2-way left turn lane. The extra width that's available in the right-of-way then can be used for bike lanes, pedestrian crossing, sometimes parking, transit stops, and that type of thing. So you can see in the picture on the left, that was the original roadway, 2 lanes each direction. And again, with no center turn lane, that means anyone in a left lane turning to the left, then they're kind of a sitting duck. If you have a lot of traffic or the speed is very high, sometimes that can surprise folks coming around a corner and they don't stop in time. So if you have a lot of rear end accidents on those 4-lane roadways, 2 lanes each direction with lots of driveway access, this might be a very good solution. Here's another example. This is one done locally. There's 4 lanes here and lots of curves going up a hill, and it's 2 S curves one right after the other. So compound curvature and lots of places to turn left into driveways, streets, and businesses. And this was converted from that 4-lane into 3-lane. So we've got 1 lane each direction, a 2-way center left turn lane, and then we've got some bike lanes over here on the edge, and then some areas that are really to be unused. But it definitely separates the vehicle traffic from the pedestrian traffic. So that's a definite benefit. Now that road diet does reduce your capacity some, so you need to do a study with traffic counts and make sure that it's going to work. But lots of advantages that not just for pedestrians, but the multiple threat crash. Like say one vehicle stops for a pedestrian, the next car, the car in the next lane doesn't. That's an issue. If you look just at vehicles, imagine in 2 ways each direction, 2 lanes each direction. You're in the left lane waiting to turn, and there are 2 cars coming toward you, but because one car is larger in the near lane and the other one's kind of hidden by it, you may say, oh, this car is gone. As soon as they get past, I'm going to make that left turn. You hit the gas and didn't realize there was another car there. So visibility is a big issue on those types of roadways, and a road diet definitely helps. So recommendations are for under 15,000 vehicles per day. Of course, there are some challenges. The public is not always happy with it. But again, public education is critical, and if it's designed right and performs right, that typically handles the questions. So, and speaking of questions, that is about all I have. So, any other questions that have come through?
No, I believe that is everything.
All
Well,
right.
we did have, I know we're short on time. One just came through that I'll read quick is what are some pavement marking or alternative solutions one can use when a class 2 bike lane is being implemented on a 25-mile-per-hour rural Main Street highway adjacent to head-in parking when reverse parking is not favorable?
I'm going to have to think about that one for a second. I'll tell you what, I will respond by email if that's all right, since we are out of time. I don't want to keep everybody any longer than we have to. But just make sure we have contact information there, and I will answer that question.
Okay, sounds good.
There we are. All right. Well, thank you all so much for your attention today. I appreciate the questions and that type of thing. So I will address that question and anything else that pops up in the chat. And I hope you all have a great day. Thank you so much.